Hello students, welcome back to the 7th video of this playlist. So in this video we will be solving question number 7 from P4 January 2024 paper. So basically question number 7 it's from integration of your P4 syllabus. Like question number 6 was also from integration, and now question number 7 it is also from integration. So we know integration chapter, it has been discussed in chapter number 6 of your P4 book. So the concepts behind this question is basically discussed in chapter number 6 of your P4 book. So in order to be able to solve this question, you should have clear idea, and you should have definitely gone through the concepts of chapter number 6 of your P4 book. So to be more specific, if I say the topics behind this question, it's basically integration by parts rule. Definitely you should have idea about that, and also volume of revolution. How to find out the volume of revolution using integration? Like it is combined of these two rules. So let's get started. Question number 7, part A. Using the substitution, it's not by parts, basically it's from substitution, since they have said it is what? Using the substitution, u equals to 4x plus 2 sine x sine twice x, or otherwise show that integration of this is what? Integration of e to the power 4x plus twice of sine twice of x cos squared x dx is equal to what? 1 over 8 times e to the power 2 pi minus 1. So we need to show that using integration by substitution. Integration by parts was in the previous question, question number 6, I think so. So either 6 or 5, either 6 or 5 we did in the previous videos, okay, whatsoever. So in this process we have to use integration by substitution. So for integration by substitution, the first thing that we need to do is what? Is to do the substitution, right? So the substitution is what here? What's the substitute there? This is for u equals to 4x plus twice of sine twice x. So in that case, what we need to do is that when you do the substitution, we need to convert all of the terms with x to u. Okay, so let's do that. Left hand side, we will start from the left hand side for part A. For the left hand side, what we have then, integration of what? Integration from pi over 2 to 0, okay, and then what? E to the power 4x sine 2 sine twice x, e to the power 4x sine what? Twice of x, then 4x plus 2 sine 2x, okay, 4x plus 2 sine 2x, 4x plus 2 sine twice x, 2 sine twice x, and then that's a large equation, times cos square x times cos square x dx, right? So we need to convert all of the terms. You can see that all of the terms here are in terms of x, so we need to convert these to u. So the substitute is what? U equals to, what's there? They said it's given in the question. The substitute is 4x plus 2 sine twice x, 4x plus twice of sine twice x. Okay, now 4x, look, e to the power 4x plus 2 sine 2x. So we got the substitute for the power of the exponential. Okay, now we need the substitute for cos x. So how can we do that? Look, we need substitute for cos x and also for dx. Okay, so what we can do, we can differentiate. If you differentiate, what you will get? Du over dx. Why I'm differentiating? To get a substitute for dx. So that would be 4 plus 4 cos twice x. 4 cos what? Twice of x. Isn't it? The derivative of u. So what we can do now is that we can make dx subject from there. Right? We can make dx subject from there. If you make dx the subject, what you will get? 1. You can do another thing. Let me show you. Dx, right? We need a substitute for dx. So we can write dx like this. Dx can be written as dx over du times du. Can we write like this? Definitely we can write like this. So in place of dx, we will represent dx like this. Fine. Now what we need to do, we need a substitute for cos squared x. Right. So to have a substitute for cos squared x, what we can do, look, I think cos squared x will get eliminated as you put the derivative of x. That is the as you put that substitute for dx. Let's see whether it gets eliminated or not. So for now, ignore the powers, ignore the intervals. Okay, so you will get what? E to the power u there. Let me write it there. You will get integration of e to the power u, right? And there you see cos squared x. So this is cos squared x, and dx can be written as what? Dx over du times what? Du, isn't it? We can write it like this. Okay, we are ignoring the limits for now. Okay, now put the values. E to the power u cos squared x times what? Dx over du equals to what? Dx over du would be 1 over, it will be multiplied 1 over 4 times 1 plus cos twice of x, and then du. So look, we have eliminated dx from here. Fine. Like, you should keep in mind that my main goal is to eliminate the terms with x, all of the terms with x. That should be your main goal, and you have to do your works accordingly. Okay. Now what we can do, look, we still got cos square x there. We need to eliminate this one. So let's do some more workings. Cos square x is now on the numerator, cos square x, and on the denominator 1 plus cos 2x. Cos 2x can be written as cos squared x minus sin squared x. Again, we can, using the double angle formula, we can write cos 2x as cos square x minus sin square x, and then 2 cos square x minus 1. So 4 times 2 cos square x minus 1. 2 cos square x minus 1, and you see there is a plus 1. So minus 1 plus 1. That's it. You see? du. Okay. Now what we can do? Integration e to the power u. Now look, cos square x at the numerator, and at the denominator it is what? 4 times what? 4 times 2 cos square x. 2 cos squared x du. Okay. Now you can easily see, you can easily understand that we are actually approaching to our goal, what we were thinking of. Okay, so now what we can write, 4 times 2, this is 8. So take this 1 over 8 outside the integral. So it would be e to the power u, and cos square x gets cancelled out. We are done with our goal, isn't it? Fine? Okay. Now, one of the good question is that how did I understand that I don't need to like make x subject from there? Because definitely if you have done past papers, then, or if you have gone through the questions from chapter number 6 of your book, then definitely you know, like sometimes we need to make x subject from the substitution, from the substitute for u, right? Like we could also make x subject from there, but I didn't approach for that, I didn't go for that. Okay, so you need to understand like what makes me think of that, what made me think of that. Like I don't need to approach this method, I don't need to make x subject from there. Look, my goal was to eliminate the terms with x from the integral. Okay, so I got the substitute for you as per the question, but the problem was cos square x dx. For dx it's pretty straightforward, like you can easily eliminate dx by just differentiating it, by just differentiating the substitute, right, u. So dx is done. Main concern is cos square x. So basically, as I try to eliminate dx by differentiating the substitute u, I got 4 plus 4 cos 2x. So try to relate what I got and what is remaining on the integral. I got 4 plus 4 cos twice x, and there I see cos square x. That means my sense says that it might be possible to eliminate cos square x by just substituting du over dx. You need to like keep coherent, like you should keep coherent with your workings, like what you are doing and what has been done, okay, and what has been asked for. You should keep these things in what, in like you should keep an eye on all of the things, what you are doing, what has been done, and what should be done. Okay, so that's how I approached. Like I didn't need to make x subject from there. Like it is very common, like students cannot make this coherent with their workings. Okay, they can't keep relationship with their workings. Okay, so if I would approach this method like making x subject from this substitute, then it would lose my time, it would take my time, right? So in exam conditions, this is a real concern for the students to get affected with this thing. Okay, so that's why I took a bit time to explain that fact. Okay, so we got the integral in terms of u. Okay, now our next step is what? Our next step to just consider the intervals. So let's go for that. So the intervals is what? The upper limit was pi over 2. So if x equals to pi over 2, if x equals to pi over 2, then what would be the value for u? What would be the value for u? If x equals to pi over 2, then put it there, you will get 4 pi over 2. There is 2 pi plus 2 sine twice of x. So sine 2 pi over 2, this is basically sine pi. Sine pi is 0. So we got 2 pi, the upper limit is 2 pi for u, and when x equals to 0, you will get the lower limit 0. Fair enough, we got the limits. Okay, so we can write the integral as how? So we can write the left hand side as what? 1 over 8 integration, the upper limit is what? 2 pi, the lower limit is what? 0, and the equation, the simplified equation after substitution, we got e to the power u du. Done. Okay, now what we need to do, just put the limits. the intervals. 1 over 8, the derivative, the integration of e to the power u is what? E to the power u, as it is. Upper limit is 2 pi, the lower limit is what? 0. So you will get 1 over 8 e to the power 2 pi minus 1. And I'm sure that that's what the question has asked for. That's the right hand side. Okay? Okay. So this was part A. Next, for part B, there is a figure 3 you can see given and a shaded region R. So basically, in this question, they asked that they have like what? The region R, it has been bounded. It is bounded. We can see in the screen. You can see in the figure. Okay. So the region R is rotated through 2 pi radians about the x-axis to form a solid. It has been rotated around the x-axis to form a solid. That is volume of revolution. So we need to find out the volume. The question asks, in the simplest form, we need to find out the volume of revolution. Hint is that you need to use your answer to part A. So let's see how can we use our answer to part A. So for part B, what's the formula for finding the volume of revolution? Part B, it should be there. What's the formula for finding volume of revolution? Volume would be what? It would be pi integration y squared dx, right? So y squared in this case is what? 6 squared, that would be 36. So take 36, you can take 36 outside the bracket, outside the integral, 36 pi, and y squared, since it is y squared, so e to the power 4x plus 2 sine 2x. So that would be e to the power 4x plus 2 sine what? 2 sine twice of x. Okay, and then it is whole squared, so it will be cos squared x. It is cos squared x dx. Okay, now put the limits, please. What would be the limits? Pi over 2 to 0. So pi over 2 to what? Pi over 2 to 0. Fine. So how could we use our answer to part A? You can see the pattern. The pattern, the integral, you can see. It's just the integration that we did in the part A. That's it. Okay. So we will just put the value that we found in part A. Okay. But reminder is that, keep in mind, 36 pi was not there. Okay. So you should have kept an eye on that definitely when you put the values. 36 pi. So 36 pi times what? 36 pi times the value we got earlier. It was 1 over 8 e to the power 2 pi minus what? Minus 1. Okay, one thing. Yeah, that's fine. Everything is fine. Nothing. So 36 over 8 is what? 36 over 8 is 9 over 2. 9 over 2 pi times e to the power 2 pi minus 1. This is the simplest form. We don't need to simplify any further. And that's the answer to part B. And that's the end of question number 7 from P4 January 2024. Hope so you have understood it in a very better way. If you have any problems, or if you haven't understood any of the part from this video, feel free to give a comment there. I'll be definitely available to answer. That's it. Thank you.